Hello, my name is Devesh Sarda and I'm an undergraduate at the UPComp lab in the University of Washington. In this presentation, I would like to talk about our work on monitoring rapid diagnostic test administration. So, what are rapid diagnostic tests? Rapid diagnostic tests, or RDTs, are medical tests that are quick and easy to administer with a limited amount of resources. Thus, they're especially suited for initial medical screening as well as point-of-care medical testing. The problem is that people who are not experienced with such tests often make mistakes in their administration, which leads to inaccurate results. Our solution to this problem is RDTCheck. RDTCheck is a smartphone application that guides users through the instructions of a RDT test. We ensure that the users follow the protocols of the test using a variety of computer vision techniques, which we describe in detail in the next slide. The application provides users with real-time feedback to correct their mistakes and prevent those mistakes from happening in the future. The RDTCheck application guides the users through the steps of the QuickVue Influenza A+B test, which is a test that utilizes a swab for sample collection. This test contains many steps that are similar to other tests that utilize a swab for sample collection, which means that a lot of the software can be generalized to other swab-based RDT tests. This application has 7 major steps, with the first two being placing the test tube inside the box and adding a buffer solution to the test tube. The application utilizes relatively similar computer vision techniques to ensure that the user has completed these steps properly. What the application does is that it takes the first incoming image and treats it as the base image. All later frames are then compared against this base image using image alignment and image subtraction to get a difference between the box in the current frame and in the base image. The application then utilizes noise reduction along with contrast detection to ensure that the test tube has been placed inside the box and that enough buffer solution has been added to the test tube. The next 3 steps all involve the interaction of the swab with the buffer solution. The application uses a CSRT-based region of interest tracker to tag the swab inside the test tube. To initialize the tracker, we need to not only provide it a frame, but also an initial bounding box. We find that initial bounding box using color thresholding. For the initial frame, we search for white in the initial frame after converting it to the HSV color space. The final 2 steps involve placing the strip inside the test tube. We use multi-scale template matching to ensure that the strip has been placed inside the test tube and in the proper orientation. We utilize a template image of the downward arrows, which not only helps ensure that the strip has been placed, but also it has been placed in the proper orientation. In our initial study, we asked participants to deliberately make certain mistakes and record if the application could detect those mistakes or not. Specifically, we asked users to make mistakes that are common in swab-based RDT tests, such as not adding enough buffer solution or not swirling the swab for a long enough period of time. We recruited a total of 7 participants, 4 male and 3 female, whose ages range from 25 to 42. All of the participants had no prior experience with RDT tests of any sort, swab-based or otherwise. We were able to measure an average error detection rate of 91.1% per step. As you can see from the table on the right, we place a special emphasis on the swirling the swab in the buffer solution case. This is because one of the most common errors in swab-based RDT tests is improper swirling of the swab with the buffer solution. Thus, we wanted to ensure that the RDTCheck application could detect that error with a high enough success rate and could provide users feedback on how to correct that mistake. Through our initial study, we were able to show that RDTCheck can accurately detect mistakes in RDT test administration. The next step is to conduct a usability study on RDTCheck. For our usability study, we want to have a larger number of participants than we did for our initial study. We also want to have participants with different experience levels in RDT test administration. This is because we want to see what role experience level has in the ability of the RDTCheck application to detect and correct the user's mistakes. After we have incorporated the feedback we received from the usability study into the application, the next thing we want to do is deploy the RDTCheck application into the field. We want to see how well the RDTCheck application does in non-controlled environment with the general public. We might want to measure how accurately it can detect and fix users' mistakes in that setting.